Okay, improper fractions and mixed numbers. How will we define an improper fraction? Okay, my numerator is bigger than the denominator. So give me an example of an improper fraction. 5/3. What else?
11/5.
11/5. Okay, one more.
7/3.
7/3. Okay, when we have improper fractions, depending on what we're doing with them, we can leave them like this or we can change them into what's called a mixed number. Okay? So improper fractions will turn into mixed numbers. What does that mean, to be a mixed number?
Whole number plus fraction.
Okay, I have a whole number and a fraction. So 5/3.
1 2/3.
How did we find 1 and 2/3?
5 divided by 3.
5 divided by 3, or here's my denominator, right, is 3. And I have more than 3. How many more than 3 do I have up here? 2. So I have 3/3 and then 2 extra. Okay, how about 11/5? Okay, so I have 2 sets of fifths, which takes me to 10/5, and then I have 1 extra. So 2 and 1/5. How about 7/3? 2 and 1/3. So I will need to be able to convert from mixed numbers to improper fractions and from improper fractions to mixed numbers, depending on what else I'm doing with my fractions.
Unless you have to show us how to put a mixed number into an improper fraction.
Okay, so how do I go back from a mixed number to an improper fraction? How would I work that out? What's the math I do here?
Denominator times the whole number plus the numerator.
Okay, denominator times my whole number plus the numerator. So let's do this one. 1 times 3 is 3, plus 2 is
5.
5. So then that goes back to 5/3. How about this one? 5 times 2, 10, plus 1, 11. And this one? 3 times 2,
6,
plus 1,
7,
7. So I'm back to my improper fractions. Okay. So denominator times the whole number plus the numerator. Okay. Multiplying and dividing fractions and whole numbers. All right, our example to start is 2/3 times 4. So I need to turn my 4 into a fraction. What's the easiest way to do that?
Draw a line, put a 1 under it.
Okay. Any whole number over 1 is still itself. Okay. So now, multiplying fractions, we just go straight across, right? So 2 times 4, 8. 3 times 1, 3. So is that an improper fraction or a mixed number? Improper. And if I want to switch it into a mixed number?
2 2/3.
Okay, so I have 3. We'll go into 8 2 times. That will give me 6, and then there's 2 left over. 2 and 2/3. So divide. 2/3 divided by 4.
Put the 1 underneath to start.
Okay, turn my 4 into a fraction.
flip it.
Then I have to flip it. So I'll end up with 2/3 times 1/4. Do I want to do anything else?
Reduce the 2 and 4.
Okay, simplify this step. So 2 goes into itself once, and 2 goes into 4 twice. Then multiply across 1/6. How about 1/6 times 3? What's the first step? Okay, turn the 3 into a fraction.
And then simplify the 3 and 6.
Okay, I want to simplify right here. So 3 goes into itself once, and 3 goes into 6 twice, and then multiply across 1/2. How about 3/5 times 5? What's the first thing I do?
Fraction.
Turn it into a fraction. Simplify. 5 goes into itself once and once. Okay, multiply straight across. I have 3/1. Or 3, right? Any number over 1 is itself. How about 1/3 divided by 3? What do I do first? Turn it into a fraction. Okay, flip it over. 1/3 times 1/3. Then multiply across. 1 times 1 is 1. 3 times 3 is 9. Let's do one more divide. How about 2/7 divided by 3? So what should I do first? Turn it into a fraction. Flip it over. 2/7 times 1/3. Will it simplify? No? So 2 21st. All right, combine the following fractions. 4/9 plus 1/3. Is that 5/12? Is that what I do?
Yeah.
Yeah? What do I do? How do I add fractions? What do I need to find first?
Oh, you gotta do a common denominator.
Common denominator. So what's going to be the common denominator between 9 and 3? 9. So I need to turn this into ninths. What do I times 3 by to get 9? 3. So 3 times 3. And on top, make sure you do the same thing. So I have 4/9 plus 3/9. 7/9. Will that reduce? Okay. How about 4/9 minus 1/3? Okay.
You still got time to fight 3.
Turn this back into ninths. So now I have 4/9 minus 3/9. 1/9.
So this fraction you have to have a common denominator too.
To add and subtract fractions, I have to have a common denominator because I want to be working with the same size of a piece. Does that make sense? So if I have a circle divided up into pieces, and I'm trying to figure out how many I have total, I want to be working with the same size piece. Okay, how about this one? 1/7 plus, set of brackets, 3 times 2/7. We talked about order of operations yesterday.
Put a 1 under the 3.
Okay, I've got to get rid of this set of parentheses, so I want to start inside, work my way out. Turn the 3 into a fraction. Okay, so this turns into 6/7. So I'll have 1/7 plus 6/7.
Just add the other down for 1/7.
Okay, they have the same denominator. So 6 plus 1, 7/7. How else can I write 7/7? 1. All right, any number over itself is equal to 1. How about 3/7 times 2/7 plus 5/49?
Gosh, in that last problem, and then in the parentheses, 3 times 2/7.
All right, we're multiplying fractions.
I actually understand how to do the problem. I'm just thinking about, so 3 times 2/7 equals 6/7,
Yes,
which is not quite a whole.
correct.
But then you add the 1/7, it turns it into.
Turns it into a whole.
It just looks weird when you have a 3 in a problem. But anyway.
And it turned
Figure
into a
it out.
1.
Yeah.
Okay, how about this one up here? Start inside brackets, right? Okay, so 3/7 times 2/7,
6/49.
6/49. How come it's not 6/7?
Because you're multiplying.
Okay, I'm multiplying. So I go straight across the top, 3 times 2, and then 7 times 7. So 6/49 plus 5/49, 11/49. Will it simplify? 11/49. Okay, one more. 3/5 times 2 minus 3/5. So where should I start?
So 1
Inside the parentheses. Turn that into a fraction. So I have 2/1. Now I'm multiplying, so I go straight across. 3 times 2, 6. 5 times 1. So I have 6/5 minus 3/5.
Should you turn the improper into improper?
No, because I want to be able to subtract straight across there. So 6 minus 3, 3/5. I don't subtract anything on the bottom. I'm working with fifths. So I have 6 pieces of 5 and I have 3 pieces of 5. So I still have pieces of 5 left, so I just have less. Any questions so far?